Wonder why this is... There we go. Wonder why this is acting so weird. Don't know. All right, look at page 43. This will be pretty easy. It says, specify any values that must be excluded from the solution set, then solve the rational equation. So I will do some of the evens for you. So number 2, n over n minus 5 plus 2 equals n over n minus 5. This is called a rational expression. Rational expressions have polynomials in the numerator and in the denominator. So it has to fit the definition of a polynomial in the numerator and in the denominator. And our first step is to get rid of all of the denominators. Okay? So what is the common denominator among all of these denominators? We treat n minus 5 as a single number. And then this has a common denominator of 1. Or sorry, a denominator of 1. So, to have a common denominator, I need to multiply this by n minus 5. Am I allowed to do that? Yes, as long as I multiply the denominator by n minus 5. Okay? Now they all have a common denominator. So if I had 6 over x plus y over x is equal to 5 over x, are the x's needed anymore? No. How come? They're all the same. Can I just get rid of them? Yes, but there's a problem. By getting rid of the x's, I have ignored the fact that there are some numbers x is not allowed to be. And in that case, x is not allowed to be 0 because we can't divide by 0. Why can't we divide by 0? Because the answer is too big. The answer is infinity. If you cut a yardstick into pieces where every piece had the width of 0, how many pieces would you have? An infinite number of pieces, right? Now you can't get there, but I'll leave you for an hour and you're chopping it into pieces, and I come in and I say, how many pieces do you have? And you said 1,000,000. And I said, well, that's not enough because I can still see the width. So you got to keep chopping. And if you get every piece so small that you can't see it, you will have so many pieces you can't count them. So we're not allowed to divide by 0. In this problem, I can go ahead and ditch all of the n minus 5s, but n minus 5 is not allowed to be 0, which means n cannot be 5. And I just keep that in the back of my mind while I solve this. N plus 2n minus 10 equals n. Well, those n's knock each other out. And then I add 10. And I divide by 2. And I get n equals 5. But I just told you that n cannot be 5. So what is the solution to this equation? There is no solution. What if my answer was n equals 4? Then we're good. No problem. So when you get rid of the variables in the denominator, you have to remember what n is not allowed to equal, and then check that against your answer. And sometimes your answer will be something like this: n equals 0 and 5. And then you double check, oh, wait a minute, this one doesn't work, and we scratch it out. Okay? Number 4. 4t over t plus 2. And you can do these out of order. I'm not concerned about that. Equals 3 minus 8 over t plus 2. This one needs a t plus 2. And I delete the t plus 2's, but I have to remember t is not allowed to be negative 2. That may or may not come into play. Solving that, we get 4t equals 3t plus 6 minus 8. Subtract 3t. And I get t equals, oh, what do you know? Negative 2. So here's another one that has no solution. We good with that? Okay. Look at number 6. What is y not allowed to equal in number 6? 1/2. Okay. Look at number 10. Number 10 says 1 over c minus 2 plus 1 over c is equal to 2 over c times c minus 2. What is the common denominator? The common denominator is c over c minus 2. So, what does this first fraction need? It needs a c over c. Does everybody understand that? What does the second one need? A c minus 2 over c minus 2. What does the third one need? Nothing. It has it all. Now, I scratch out the denominators, but I remember c is not allowed to be 2 or 0. Okay? So c plus c minus 2 equals 2. And I get 2c equals 4. So c equals 2. Ouch. No solution. I went really fast. Are you guys following? Everybody good? What's that? Yeah, and then the one time it's not, you'll miss it. All right, number 14. 3 over 4n minus 1 equals 2 over 2n minus 5. What is the common denominator in this case? Well, if I had x over 3 equals x over 2, well, let's do x plus 1 over 2. The common denominator would be 3 times 2 because they don't have anything in common. So in this case, my common denominator is 4n minus 1 and 2n minus 5. So the one on the left needs a 2n minus 5. And the one on the right needs a 4n minus 1. And I'm not even going to worry about writing it in the denominators because I know they all go away. But n is not allowed to be what? 1/4 and 5/2. Everybody understand that? Okay. So 6n minus 15 equals 8n minus 2. So subtract 6n and add 2. Negative 13 equals 2n. So n is negative 13 over 2. Is that a valid solution? Yes. Finally. This one finally had an answer. Okay, we better do 18. 18 looks really easy, but it's a little more complicated than you think. What is the common denominator? X. So this needs an x, and this needs an x, and I can drop the x, but I need to remember that x is not allowed to be 0. Okay? Now I'm left with x squared minus 10 equals negative 3x. What do I do here? It's quadratic. Move everything to one side, solve for x using factoring. X squared plus 3x minus 10. Are there factors that multiply to be negative 10 and add to be positive 3? X minus 5 and x plus 3. Minus 5 and, sorry, plus 5 and minus 3. So x is, holy cow, can I go back to bed? There we go. Just listen to what I mean. Don't listen to what I say. Negative 5 and 2. Are those valid solutions? Yes, both of them are. So we're good. Okay. Why don't you just go ahead and do the odds? Yeah, let's just do the odds.